Alright guys, so I'm just going to warn you that in this video I'm going to throw quite a bit of information at you because we're going to look at everything that happens behind the scenes or under the hood when we run asynchronous code in JavaScript. So if this confuses you, don't worry about it, that's completely fine. You'll learn more about this as we move along and as we look at syntax and different capabilities that we have in terms of asynchronous code. Now, as I said in the last video, JavaScript is synchronous by default or at its core, and it's single-threaded, so it runs on a single thread of execution. So each operation is going to run, it gets executed line by line. In this case, we just have a bunch of console logs, but where we run into an issue is where one of these operations takes a while, because like I said, we have to wait for one operation to finish for the next one to continue. Okay, so if you're fetching data from a server, or if you're in Node.js and you're writing or reading to a file, those are operations that might take a while. And what I mean by a while is a few seconds or even a few milliseconds, because that can be a long time in programming. Now, when an operation takes a while and basically holds up the line, that's called blocking code or blocking operations, and it blocks the flow of the program until it completes. Non-blocking code refers to code that does not block execution. So what I want to do is show you two examples of blocking code and non-blocking code. And don't worry about it if you don't understand this code. I'm going to explain what it does, and I just want you to see the difference between the two. So both of these, we're using Node.js, which is a JavaScript runtime, so we can run JavaScript right on our computer or right on a server, and we have access to the file system and so on. So what we're doing in both of these is bringing in the FS module, which is the file system module that has a bunch of methods on it to work with files. And in this case, what we're doing is reading the data from a file and then console logging it. Now, there's two different methods that we're using. On this side, it's using read file sync, which is synchronous, and this is blocking code. On this side, we're using read file, which is asynchronous and non-blocking. So I'm going to explain the flow of both of these. So on this side, we're calling read file sync, so we're getting whatever data from that text file, and this is going to block the rest of the code. So we have to wait until this finishes, right? So we have to wait until we get the data from the file and put it in this variable before we can move on. Once that's done, then we log the data from the file, and then this right here, this for loop, is just calculating the numbers from 1 to 10, calculating the sum, and then console logging it. So what we get as a result is the text from the file, right? Because we go through, we pause and wait for the data to be read, console log the data, then we do the calculation. Okay, on this side, what we're doing is calling read file, but this is an asynchronous method which takes in a callback function. So you can see we're passing in a function, and inside that we're console logging the data. Now the way this works is once this is complete, it'll run the callback, which console logs the data. But it's not going to pause here. It's going to keep going and execute the rest of the code. Okay, so what happens is we see the sum first, because while this is calculating, we continue, it console logs the sum, and then once this is done, it fires the callback off and then logs the data from the file. Now I'm going to show you a diagram that can be a little overwhelming at first, but I'm going to break it down for you a little bit. So this yellow box here represents the JavaScript engine, or when I say JavaScript at its core, or the core language, this is what I'm talking about. And this includes the call stack, this includes the functions on the call stack, the global execution context, the memory heap, which includes variables and objects. So this is core JavaScript, right? And this is synchronous. Everything happens line by line. Now, in addition to that, whether we're in the browser or in Node.js, we have these additional APIs that give us asynchronous capabilities. Okay, so that's what we mean when we say JavaScript is synchronous, because the JavaScript language itself is synchronous, but we can write asynchronous code with these APIs. Now, these are not part of the core JavaScript language, and we can see that if you just go to any web page, doesn't matter, and just open up your console and type in window. which we've done a few times before, this gives us the window object. And this is created during the creation phase of the global execution context. We talked about that earlier as well. Now, if we scroll down to, let's see, go to the S's here, and you'll see that we have set timeout available on this window object, as well as set interval. And if we go up here, you'll see that we also have fetch. So these are not part of the core JavaScript language. They're just available to us within our environment. So that's what I want you to kind of grasp here. All right, now, if we use set timeout as an example, what happens is we're able to pass in a callback, right? Just like you saw on the last slide with the read file method, we could pass in a callback, and when that's done, whenever that task is done, that callback gets fired. Now, what goes on under the hood is that callback gets registered and it gets put on something called a task queue, or sometimes called a callback queue or an event queue. And a queue is a data structure just like a stack. We talked about stacks earlier and how they're last in, first out. So the last thing put on is the first thing put out. A queue, however, is first in, first out. So the first thing put on is the first thing out. So it basically just cycles through like this. All right, so when we call set timeout or anything that has a callback, it gets registered, it gets put on that task queue, and we have something called an event loop, which monitors the task queue and the call stack. And whenever that functionality completes and the callback is put in here, what happens is once the call stack is empty, it keeps getting checked by the event loop, then the next callback is put on. Okay, so first in, first out. And you can think of the event loop kind of as like one of those revolving doors at the mall that just keeps spinning. And when there's people, then it lets them in and then lets them out the other side. So that's kind of what we're doing here. When the call stack is empty, the event loop lets in the next callback, spins around, puts it in to the call stack to get executed just like any other function. Now, in addition to callbacks, we also have promises to work with asynchronous data. And I'm going to talk about promises and show you how to create them and what the syntax is like in a little bit. But here I just want to show you that they work a little bit different when it comes to, under the hood or behind the scenes. So the fetch API is an example of an API that uses promises over callbacks. And the difference here is that they don't get put onto the standard task queue like standard callbacks do. So they get put on something called a micro task queue, also called promise jobs. And it works the same as the task queue in terms of it being a queue data structure, which is first in, first out. So it works the same, but there is a bit of a higher priority than the standard task queue. All right, so that's how they work under the hood. What I want to do now in the next video and for the rest of the videos in this section is look at some of these APIs. I want to look at callbacks. We'll talk about callback hell, and we'll look at promises, and we'll even look into the XHR object to make HTTP requests. And then in the next section after that, we're going to look at the fetch API and something called async await, which is an alternate way to deal with promises. All right, so we got to have a lot of asynchronous JavaScript ahead of us.